You open an app, you type a few words, you hit send, and somewhere a message crosses an entire continent before you've finished exhaling. It feels instant. It feels like magic. It feels like there's a giant machine somewhere, quietly running the whole show. But what's actually happening is far stranger. There is no giant machine. There is no headquarters. There is no single room, no single server, no single company that the internet lives inside. What if the internet was built on purpose to have no center at all? Rewind to the 1960s. The Cold War is at its coldest. A researcher named Paul Baran, working at the Rand Corporation, is given a strange problem to solve. How do you build a communication network that survives an attack? Not a network that avoids damage, a network that keeps working even after parts of it are destroyed. Baran's answer broke every assumption people had about networks at the time. Phone systems worked through central switchboards. One hub, one point of failure. Baran proposed something almost rebellious. Break every message into small pieces, send those pieces out in all directions, and let the network figure out the best path on its own. No single route, no single hub, no single point anyone could take down. He called it packet switching. It sounds technical. It isn't really. Imagine tearing a letter into a dozen scraps, mailing each scrap through a different route, and trusting that they'll all reassemble perfectly at the other end. Strange, right? But it works, and it works precisely because no single scrap and no single road matters more than any other. That idea sat mostly untested for years. Then, in the early 1970s, two engineers named Vint Cerf and Bob Kahn took it further. They designed the protocol that would let entirely different types of networks talk to each other as if they were one. They called it TCP/IP. You've almost certainly never seen those four letters do anything visible. But every video you've streamed, every message you've sent, every page you've loaded has traveled inside that protocol, hopping between machines that don't know or care what country they're in. Here's the part that should stop you for a second. Nobody owns TCP/IP. Nobody runs it from one location. It isn't stored on a server you could point to on a map. It's a set of agreed-upon rules, followed by millions of independent machines, all cooperating without a boss. So who's actually in charge? That question gets stranger the deeper you go. You'd think somewhere there has to be a control room. And there sort of is one, except it's not what you'd expect. When you type a website's name into your browser, your device needs to translate that name into a numerical address. That system is called DNS, the Domain Name System, and at its foundation are 13 root server clusters scattered across the globe. 13 sounds small. It sounds fragile. But each of those 13 isn't one machine. It's hundreds of physical servers, copied and mirrored on every continent, run by different organizations that don't even work for the same company. Take one down, and the others answer instead. Take out an entire continent's worth, and the rest of the system barely notices. It was designed deliberately to survive its own failure. Think about what that actually means. The system you use to find literally anything online has no true single point where it lives. It exists as a pattern, copied everywhere, agreed upon everywhere, owned nowhere. Now here's the twist that usually surprises people the most. You've probably heard the phrase, the cloud, 1,000 times. It sounds like a place, a single, soft, glowing location where your photos and messages float, waiting for you. It isn't. There is no cloud, not in the way the word implies. Your data doesn't sit in one building. It's split, duplicated, and scattered across data centers on multiple continents, run by companies like Amazon, Google, and Microsoft, specifically so that losing one building, one city, even one country, doesn't mean losing your information. That's not a poetic metaphor. That's an engineering requirement. Redundancy isn't a nice bonus feature. It's the entire foundation the modern internet is quietly standing on. So why does it feel centralized if it isn't? Because the experience of using the internet has been centralized, even while the infrastructure underneath stays decentralized. A handful of platforms decide what you see, what gets recommended, what trends. That part is real. But peel back the apps, peel back the platforms, and what you find underneath is still that same 1960s idea. No single point of failure, no single authority, no center. Here's a study worth sitting with. Researchers at the University of Oregon have spent years running an ongoing project called Root Views, mapping in real time exactly how data actually moves across the global internet. What they consistently find is that a message sent from your phone might travel through a dozen different networks, run by a dozen unrelated companies, before it ever reaches its destination. No single company controls that entire path. No single company even knows the entire path. The internet routes around problems the same way water finds the fastest way downhill, adjusting itself second by second without asking anyone's permission. Doesn't that change how you think about hitting send? Every message you've ever sent has been quietly negotiated by machines you'll never meet, owned by companies you've never heard of, following rules nobody enforces except by choosing to follow them. It's less like a postal service and more like a massive unspoken agreement between strangers who've decided, collectively, to keep the world talking to itself. And maybe that's the real reframe. You were taught to think of the internet as a place, a destination, somewhere you go. But it was never a place at all. It's a behavior, a pattern of cooperation, repeated by millions of machines, none of them essential, all of them replaceable, none of them the center. Which means the moment you send your next message, you're not reaching toward a machine in the sky. You're relying on a decades-old idea that the safest system is the one with nobody left to attack, no center to hit, no headquarters to take down. Just an endless distributed handshake happening quietly every single time you open an app and hit send.